The strain energy is stored in the beam with the flexibility EI and the loaded as shown in figure here. Total length is equal to L plus 12 that equal to 4L. One point load is acting at point B, which is L meter from the left support. One point load is acting at point C, which is L meter from D. Both the point loads are equal, so this one is a case of symmetrical loading, and therefore we have reaction at A and the reaction at D will be equal. So due to symmetrical loading, we have reaction is equal to P plus P divided by 2, that equal to P, as well as we have reaction at D, that will be equal to dy is also equal to P. And we have given here the four choice. We have strain energy U is same as equal to strain energy in AB, plus we have strain energy in BC, plus we have strain energy in CD. One type of problem already we have done here. For AB and for CD, the figure is symmetrical. So in this case, we have strain energy AB is same as the strain energy in the CD. So you have to find out here what is the strain energy in AB. For this one, we'll make a cut and we'll exclude the point B, and we'll develop the FBD for the given section. So let's consider here the FBD of the segment AB. At A, we have one load is acting. That is basically a reaction at A is equal to P. We have a section at a distance equal to X. And limit for this one is same as equal to 0 less than equal to X less than equal to L minus. L minus means we have excluded the point B. So one shear force will act in a downward direction, that will be V of X. Moment of P above the section plane is clockwise, so we'll show here one anti-clockwise moment, and this value of mx directly we'll write down this time will be same as equal to P multiplied by X, and our limit is from 0 to L. Next we'll consider the segment BC only, that is the section plane will vary from B to C. So section plane will be anywhere between B and C, and its distance will change from B. So this one is representing the section plane and is from B to C. B to C means we have L to 3L. So we have range is L less than equal to X less than equal to 3L minus, means we have excluded the point C. At point A, we have one point load is acting, that is the reaction is equal to P, and this P from the section plane at a distance equal to X. So we have section plane at a distance equal to X for the load P. Then one load is acting at point B. That load is acting in a downward direction and has the same magnitude equal to P. Now total distance here is equal to X here from the section plane. Already we have covered the distance equal to L. The distance of point B from the section plane will be equal to X minus L. X minus L. In this case, the shear force will act vertically downward. Let's say the shear force is equal to Vx, and one moment will show in an anti-clockwise sense, that is the internal reaction equal to mx, and this value of mx we can find out by applying the summation of moment equal to 0, and we'll take here anti-clockwise positive. So this moment is anti-clockwise, so we have m of x. Moment of P into X is clockwise is negative, is P into X. Moment of this value of P will be anti-clockwise, will be positive, is P into X minus L will be equal to 0. So minus P of X and P of X will be cancelled. Moment mx will be same as equal to P multiplied by L. So minus Px and plus Px cancel, we have minus PL, will shift to the right side, will be PL. So in this case, we have total strain energy will be equal to 2 times the strain energy in segment AB plus we have strain energy for the segment BC is equal to 2 times. Strain energy for AB will be equal to integral. For AB, we have limit is 0 to L. We have mx square divided by 2 times of EI multiplied by dx, plus strain energy for BC. Limit is from L to 3L, so we have integral from L to 3L. Again we have mx square into dx divided by 2 times of EI. So 2 times of EI we can take it common. So we have 1 upon 2 times of EI is taken common. 2 is left here. We have integral of mx square. Integral of mx square, and we have mx equal to px. So we have p square into x square into dx, and we have limit is from 0 to L, plus mx square will be equal to p square L square. So we have integral from L to 3L, that will be p square multiplied by L square multiplied by dx, and the bracket closed. So p square here and p square here can be taken again common. So we have p square divided by 2 times of EI multiplied by 2 times integral of x square is x cube divided by 3, that will be equal to L cube divided by 3, plus L square is a constant term. Integral of dx is same as equal to x, that equal to 3L minus L, and the bracket complete. So L cube here and L cube here can be taken common. So we have p square L cube divided by 2 times EI. What is left here is 2 by 3, and here we have 2L cube. So we have left here with 2. LCM is equal to 3. We have 2 plus 6, that will be 8 by 3. 8 by 3 and 2, that will be equal to 4 by 3. So finally we have strain energy will be equal to 4 by 3 times p square L cube divided by EI divided by EI. 4 p square L cube. So actually it should be L cube divided by 3 times of EI. Choice C is correct. A simply supported beam AB of length equal to L is subjected to the loads that produce a symmetric deflection curve with a maximum deflection delta at the midspan. So we don't know here what type of load, but we know the deflection curve, and the maximum value of delta is occur at the center, and at any point here from the point A, we have deflection is given as delta into sine of pi x divided by L. So this blue line represent here the deflection curve at any distance x. So at any distance x, we have deflection is equal to y, and this deflection related to the center deflection. At center we have maximum deflection is equal to delta. At any distance x here, we have deflection is equal to y, and that deflection is given as y is equal to delta multiplied by sine of pi into x divided by length L. We want to find out here what is the strain energy stored for the given length of beam is equal to L. Strain energy in the beam AB can be calculated as integral of mx square divided by 2 times of Young modulus into I multiplied by dx. We have lower limit equal to 0 and upper limit equal to L. Load is not given this time, rather we have given the value of deflection at any distance x is given, which is delta into sine of pi x divided by L. Delta is remain constant here, which one is the deflection at the midspan. In the deflection, we have already done the equation that we have product of E into I, and the second derivative of deflection with respect to x square is same as equal to mx. Here we are interested in mx square divided by 2 times of EI. So we can solve here for mx. So we have mx equal to E into I. We have second derivative. So we have d dx square of y. Y is equal to delta into sine of pi into x divided by L. So we have d square will be equal to E into I. First we'll take first derivative. So we have d dx into derivative of delta into sine will be cos. So we have delta into cos of pi x divided by L, and you have to take the further derivative of a composite function that will generate term pi into L. So delta pi L can be taken outside. We can take out here delta common. Even pi divided by L can be taken common. So what is left is ddx of cos of pi x divided by L. Derivative of cos will be sine. So we have e into I into delta into pi divided by L minus sine of pi into x divided by L, and is further multiplied by the derivative of composite function, that equal to pi into L. So finally we are getting this answer as mx equal to e into I. We have pi into L and pi into L, so we have pi square divided by L square multiplied by delta and minus of sine pi of x divided by L. But what we are interested is mx square. So we have mx square will be equal to e square or ei whole square into pi to the power 4 divided by L to the power 4 into delta square and the square of sine term, that will be sine square of pi x divided by L. This entire term you have to substitute here and you have to solve the given integral. So we can calculate here the strain energy in the bar AB, that will be equal to integral from 0 to L. Mx square will be equal to e into I. We have square of it multiplied by pi to the power 4 and is divided by one term of 2 times of ei I will write down first. Then I have to write down here L to the power 4. Then we have delta square into sine square of pi x divided by L, and is to be integrated with respect to dx. So this term of ei is get cancelled here, and we can take out here ei pi to the power 4 delta square divided by 2 times of L to the power 4 outside the integral sign. Then we have sine square term is left. We know that sine square theta is same as equal to 1 minus cos of 2 theta divided by 2. So we'll do this substitution and we'll solve this integral. So let's take out here pi to the power 4 common. Then we have ei common. Then even delta to the power 2 is also common, divided by 2 times of L to the power 4, and sine square term we can replace as 1 minus cos of 2 theta, that is equal to cos of 2 times of pi into x divided by L, and this whole term is further divided by 2. So that 2 I will adjust outside, is 0 to L, and this entire term you have to integrate with respect to dx. So slightly complicated solution now. So this part we'll solve first. Integral of dx is same as equal to x. Then we have integral of cos x will be equal to sin x. So we have minus of sine into 2 pi x divided by L, and since it's a composite function, so you have to divide by derivative. Derivative is same as 2 pi divided by L, and we have limit is from 0 to L. That will be equal to x limit is L minus 0. So we have first term is L minus 0. Then we have minus L will come in numerator divided by 2 pi into sine of x will be equal to L. L and L cancel. We have sine of 2 pi, that is sine of 360, that equal to 0, minus we have again sine of 0, that will be again 0, and the bracket closed. So from this one we are getting only value of L. This term will be equal to 0. Sine 2 pi, that is sine of 360 is 0, sine 0 is 0. So we have only L is left. So we'll substitute for this and we'll write the final equation. So we have strain energy AB will be equal to pi to the power 4 divided by E multiplied by I multiplied by delta square divided by, we have 2 into 2, that will be equal to 4. We have L to the power 4 and this term is L, so we have divided by L cube. Pi to the power 4 EI delta square 4L cube. It means that our choice A is correct choice. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.